The Great Wall of China, a serpentine titan stretching across vast landscapes, stands as humanity's most ambitious construction project. Its sheer scale inspires awe, but the true marvel lies not just in its visible grandeur, but in the unseen stories of its creation. For centuries, this colossal barrier was forged through unparalleled human effort, ingenious engineering, and an economic investment that reshaped empires. This film unearths the hidden methods, the financial sacrifices, and the innovations behind the world's longest structure. The story of the Great Wall truly begins with the unification of China under the Qin dynasty in 221 BCE. Emperor Qin Shi Huang, driven by a need to defend his nascent empire from northern nomadic incursions, initiated the consolidation and extension of earlier fragmented walls. This wasn't merely a defensive line, it was a physical manifestation of a unified China, demanding an unprecedented mobilization of resources and labor across an enormous, newly consolidated territory. The earliest significant sections of the Great Wall, particularly during the Qin dynasty, were primarily constructed using rammed earth techniques. This involved compacting layers of earth, gravel, and sometimes sand or clay, within wooden frames. Once sufficiently compacted, the frames were removed, leaving behind a remarkably sturdy wall. While seemingly primitive, this method was effective and utilized readily available materials, forming the foundational approach for many early defensive structures across the diverse and challenging terrain. Building the Qin Wall came at an unimaginable human cost. Millions of laborers, including soldiers, convicts, and conscripted peasants, were forced into service under brutal conditions. The work was relentless, the terrain unforgiving, and supplies often scarce. Disease, exhaustion, and accidents led to extremely high mortality rates, turning stretches of the wall into vast burial grounds. This forced labor system became a defining, tragic characteristic of its early construction. The financial investment in Qin Shi Huang's wall projects was immense, placing an unbearable strain on the imperial treasury and the common people. Taxes, both in grain and labor, were levied relentlessly. Resources vital for other parts of the empire were diverted to this colossal endeavor. This immense economic burden, combined with the brutal conscription, ignited widespread peasant revolts, ultimately contributing to the swift collapse of the Qin dynasty shortly after its founder's death. Even in its earliest form, Qin engineers demonstrated remarkable ingenuity in adapting the wall's construction to the natural landscape. Instead of battling the topography, they strategically incorporated it. The wall often followed mountain ridges, traversed valleys, and secured strategic mountain passes. This wasn't merely practical, it maximized defensive advantages by utilizing natural barriers, allowing the use of less material in certain areas while concentrating effort on critical choke points. Following the Qin dynasty, subsequent empires inherited the challenge and the legacy of the wall. For centuries, various dynasties maintained, extended, or allowed sections to fall into disrepair, depending on their perceived threats and available resources. It wasn't a continuous, single project, but a series of overlapping constructions and fortifications. This cyclical pattern of investment and neglect continued until the rise of the Ming dynasty, which would embark on the most ambitious building phase of all. The Ming dynasty, ruling from 1368 to 1644, faced renewed and persistent threats from nomadic tribes to the north. Learning from past experiences, they initiated a comprehensive and unprecedented reconstruction and expansion of the Great Wall. This was not just repair work, it was a grand strategic vision to create a truly formidable and durable defensive system, leveraging centuries of accumulated knowledge and significantly advanced construction techniques. It marked a peak in both engineering and financial commitment. A hallmark of Ming dynasty construction was the widespread adoption and mass production of baked bricks. Unlike the rammed earth of earlier eras, bricks offered superior durability, standardized dimensions, and allowed for more intricate construction. Vast brick production hubs were established near construction sites, with advanced kilns producing millions of bricks. This shift to standardized, high-quality materials revolutionized the speed and resilience of wall construction, setting a new benchmark for engineering. To bind their superior bricks in cut stone, Ming engineers employed an extraordinary innovation: sticky rice mortar. This remarkable composite combines slaked lime with glutinous rice flour, creating a mortar of unparalleled strength and water resistance. Scientific analysis has confirmed its incredible binding properties, making Ming sections of the wall exceptionally robust and able to withstand centuries of weathering. This culinary-inspired secret was a critical engineering breakthrough for structural integrity. Beyond bricks, huge quantities of cut stone were essential, especially for foundations, gateways, and critical fortifications. This necessitated extensive quarrying operations, often in remote mountainous regions. Extracting massive stone blocks required skilled labor, specialized tools, and immense physical effort. The logistics of transporting these heavy stones from quarries to often distant construction sites presented monumental challenges, requiring careful planning and coordinated human and animal power. Moving millions of tons of materials across mountains, deserts, and treacherous passes was arguably the greatest logistical challenge. Simple carts, human chains, and pack animals like donkeys and goats were indispensable. Ropes and sleds were used to drag heavy stones up steep inclines. Ingenious systems, like temporary ramps and even simple pulleys, were devised to overcome formidable gradients. These low-tech, yet highly effective, methods were crucial to delivering materials to remote construction fronts. The scale of the Ming construction effort was staggering. At its peak, it's estimated that over 1 million workers were engaged in building and maintaining the wall. This massive workforce comprised soldiers, forced laborers, and skilled artisans. Managing such a vast, geographically dispersed project required sophisticated organization, military discipline, and complex supply lines to feed, shelter, and equip these countless individuals, sustaining work across immense distances for decades. The Ming dynasty's investment in the Great Wall was a monumental financial undertaking, financed primarily through the imperial treasuries. This meant significant state funds were allocated year after year. Beyond direct treasury spending, local populations contributed through taxes, labor, and supplies like grain and livestock to support nearby garrisons and construction crews. This comprehensive financial commitment represented a long-term strategic investment in national defense, a conscious choice to secure the empire's borders at great expense. Ming engineering evolved beyond just a wall; it became an integrated defensive system. Watchtowers, spaced strategically along the wall, served multiple functions, signaling through smoke and fire, storing weapons and supplies, and housing garrisons. These towers were often 2 stories high, built with defensive loopholes and battlements. The wall itself featured ramparts for soldiers to traverse, and battlements with crenellated tops, providing cover while allowing defenders to fire upon invaders. To ensure the long-term integrity of the wall, Ming engineers incorporated effective drainage systems. Given the varied climates and rainfall patterns along its immense length, managing water runoff was crucial for preventing erosion and structural damage. Gutters, culverts, and strategically placed openings were built into the wall's structure to channel rainwater away, preventing it from accumulating and weakening the foundations. This foresight in water management was key to its enduring stability. The construction of the Great Wall, particularly its more sophisticated Ming sections, relied on a range of surprisingly simple yet effective tools. Levers, pulleys, and rollers were fundamental for lifting and moving heavy stones and bricks. Specialized hammers, chisels, and iron picks were used for quarrying and shaping materials. While lacking modern machinery, the ingenious application of basic mechanical principles allowed ancient Chinese engineers and laborers to achieve feats of construction that still astound us today. The wall's route was never arbitrary. Ming military strategists and engineers meticulously planned its course to maximize defensive effectiveness, always integrating with the natural landscape. It snaked along the crests of mountain ranges, utilizing natural heights as additional barriers, and strategically blocked crucial passes and valleys, the most likely invasion routes. This intelligent adaptation of topography showcases a sophisticated understanding of defensive architecture and landscape engineering. The Great Wall, regardless of dynasty or construction method, stands as a testament to immense human resilience and sacrifice. Each brick laid, each stone placed, represents countless hours of grueling labor, often under threat of harsh weather, starvation, and violence. The story of the wall is inseparable from the stories of the millions who built it, their lives woven into its very fabric. It is a monument born of strategic necessity, imperial will, and the sheer, enduring strength of its builders. Even after its primary construction phases, the Great Wall demanded continuous financial investment for maintenance. Patrols, repairs against weathering and minor damage, and garrison supplies were ongoing costs for centuries. Neglect meant rapid deterioration, especially for rammed earth sections. The sheer scale meant constant allocation of resources, highlighting that the cost of the wall was not a one-time payment but a perpetual expenditure, a burden carried by successive imperial treasuries to preserve its defensive purpose. Today, the Great Wall is no longer a military barrier, but its original purpose and the incredible efforts behind its creation continue to resonate. It is a powerful symbol of China's ancient strength, engineering prowess, and the determination of its people. The raw, often brutal, methods of its construction, the vast financial drain on empires, and the ingenious solutions to impossible problems tell a gripping story of ambition, sacrifice, and an enduring human desire to protect what is cherished. From the crude rammed earth of the Qin to the sophisticated brickwork of the Ming, the Great Wall's true story is etched into its very stones. It's a saga of innovation under duress, of economic might marshaled for defense, and of human will pushed to its limits. The Great Wall invites us not just to marvel at its scale, but to contemplate the engineering secrets it holds, the financial investments it demanded, and the countless hands that shaped this extraordinary testament to ancient human endeavor.